Hello students, I welcome you all on my YouTube channel. In this video, we will be discussing conjugate of a matrix and a tranjugate of a matrix. See, the concept of conjugate matrix, we generally talk in the complex numbers, right? If we are working in the complex number and z is the any complex number a plus iota b, then its conjugate is denoted by z bar and it is equal to a minus iota b. Similarly, the conjugate of a matrix comes into the picture when entries of a matrix is complex number. Okay, when entries of a matrix are complex. So see, if this is a matrix 2 by 2 matrix and its entries are 2 minus 3 iota, 4 plus iota only, and 2 only, right? If this is a matrix and we want to find out its conjugate, then it is denoted by a bar and it is equal to, in this a bar conjugate of this matrix, we are going to change I to minus I, right? So thus in this way this matrix would become plus 3 iota and this entry change into 4 minus this 4 minus iota minus iota and 2 as it is, because it is not a, right? So this is a conjugate of a matrix. Now if we take a transpose of this matrix, okay, transpose of a conjugate, it is equal to 2 plus 3 iota, 4 minus iota and minus iota. Okay, so this thing is known as Tranjugate. Okay, Tranju means it is transpose plus, okay, so that's why it is called Tranjugate of a matrix. It is denoted by a, okay, denoted by, that means a theta is equal to a transpose conjugate, or you can say a conjugate. Both are equal, they can be changed, okay, they can be changed. Now based on this we classify matrices into we gives we have two types of matrix, right? Hermitian matrix and Skew Hermitian. Let me write it here. Matrix Skew like symmetric matrix and skew symmetric matrix. Symmetric and skew symmetric are the types of matrix when we are working in when the entries of the matrices are real numbers. But Hermitian and skew Hermitian matrices comes into the picture when we are working with the matrices whose entries are complex, right? Same is the case here, like symmetric and symmetric matrix. If a theta is equal to a, then matrix is known as Hermitian matrix. If a theta is equal to minus a, then this matrix is known as Hermitian, right? So in this way, as there was the case, I used to I told you there that if matrix is a symmetric matrix, then aij is equal to ai. Okay, so this was the case here. Similarly, if you see, if you are having matrix a is equal to, this is the matrix, right? Now if you take transpose sorry, if you take conjugate of this matrix will become this. And now if you again take its transpose, then it would become a ij, sorry, it would become a ji now after transpose. So since you see this is nothing but a theta, so a theta is equal to a conjugate ji. Since for a Hermitian matrix these two things are equal, so we can say this all implies aij is equal to aji conjugate. Comparing, we get aij is equal to aji, right? So this is the property of Hermitian matrix. Alternatively you can write it as, okay, alternatively you can write it as aji is equal to aij. So this is the main property of Hermitian matrix which you will have to, right, if you are asked to prove it, you prove it as it is. Okay, so now you see, nextly if we talk about diagonal elements, see what sort of diagonal elements it would be having. Okay, so for diagonal elements we know, for diagonal elements I is equal to j always, right? We know. So therefore if we are working in Hermitian matrices, therefore for diagonal elements aii must be equal to aii, right? Okay, so if you take, this is some complex number, okay, a plus iota beta, it is equal to a minus iota beta. Okay, so a cancel, so take this imaginary part to the another side, you will be getting 2ib is equal to, since you know 2 cannot be 0, iota cannot be 0, this implies b is equal to, oh, if b is equal to 0, this means this part is not present in the scenario, right? So b is 0, it means aii is equal to a only. Therefore we come to the conclusion that diagonal elements of Hermitian matrix are purely real. Okay, purely. So keep this thing in your mind also, that diagonal elements of a Hermitian matrices, Hermitian matrix, are always purely right. Now we see same property for skew Hermitian. We are going to see some properties of skew Hermitian matrix. Okay, skew Hermitian matrix. Okay, so see, for a skew Hermitian matrix, theta is equal to minus a. So see here, if a is equal to aij, this implies it would be equal to aij, this is I bar, and after transpose it would be coming a ji. Now ji, ij will be becoming ji and bar. Okay, so it is nothing but a theta is equal to a bar j. We know this thing is equal to, it is equal to minus A, because A is Hermitian matrix. Okay, you can write it initially that let A be Hermitian, Q Hermitian. You can write it here. So it is equal to minus A. So minus A is equal to AJI. Now nextly you see it is equal to A is equal to A IJ is equal to AJI bar. Okay, you can take it inside, and then on comparing you come to know that minus Aij is equal to A, right? If you take a minus sign to the another side, it becomes Aij is equal to minus Aji. So this is the property of skew Hermitian matrix, that in skew Hermitian matrix Aij is equal to minus Aji bar. Okay, and when it was a Hermitian matrix, Aij was equal to Aji bar, right? Minus was not there, right? Now we see the what happens when what are the properties of diagonal elements in, right? As we saw in this Hermitian matrix, that in Hermitian matrix diagonal elements were purely real. Okay, let us try to find out some same property for this Hermitian. Okay, let's look at the diagonal elements. For diagonal elements, we know I is equal to always j. So for in case of Hermitian matrix, aii would be equal to minus aii bar, right? So see, if aii is some element a plus iota beta, then it must be equal to minus of conjugate of this number, right? Conjugate of this number is this. Okay, so now to see a plus iota b is equal to minus a plus iota b. So iota cancel and a comes to the another side, so 2a is equal to 0. This implies a is equal to, so in this case diagonal elements, for the diagonal elements real part is okay, real. So this implies real part is 0. If real part is 0, it means in case of diagonal elements only imaginary part is present, right? So therefore we can conclude it by saying that diagonal elements real part is 0, that is they are having only imaginary parts, okay. Diagonal elements are purely imaginary, okay. So for example, I'm taking some examples of Hermitian and Skew Hermitian. 2 by 2, see here a 2 iota 3 plus iota 3 minus iota 4 iota. Okay, see, if I take transpose and conjugate simultaneously, this would be transposed. Okay, this would, we are changing this, so this will be coming here, conjugate. Okay, let's firstly I'm taking simultaneously both conjugation and transpose. It would become yes. Now it would become 3 plus iota, and it is yes, right. A theta, it is equal to, now you see what is a minus minus. If you multiply this by minus sign, then it would become 1 second, must be minus 3. Okay, so when you are making it minus, this is also minus, this would be so. Okay, so you just you are going to add minus 3 here. Okay, and not here. Let me write it once. Confused, write it here. See, a is equal to 2 iota 3 plus iota minus 3 minus 4 iota. Okay, now transpose and conjugation yields minus 2 iota 3 minus iota. Okay, you will be also I think, let me take it one turn by turn. Okay, firstly you just take transpose. So after transpose, it is becoming minus 3 plus iota. Yes, then you take, okay, so now minus 2 iota 3 minus iota minus 3 plus iota. Yes, so this is your a theta. Okay, a theta is equal to minus 2 iota minus 3 plus iota 3 minus iota minus 4. Now let us find out what is a. See, if you take out minus sign from here, it gives 2 iota 3 minus 2 iota, it would become minus 3 plus iota, and right. So see, what was your a. So we just we didn't change the sign. Okay, here we correct it. Okay, write this 3 plus iota, right. It is 3 plus, then it would be negative. Okay, here it would be negative, would be negative. it would be positive. Okay, so which is equal to minus a, right? So therefore a theta is equal to minus a, hence you can say this is Q Hermitian matrix. One more example I'm going to take for you, because it was I can just confuse up the steps, right? Okay, another matrix B is equal to 5 iota 3 minus 7 iota minus 3 minus 7 iota, and now you see what is A conjugate. A conjugate is minus iota 3 plus 7 iota minus 3 plus 7 iota minus. Okay, now take transpose of this matrix. It would be minus 5 iota 3 plus 7 iota minus 3 plus 7 iota minus. So B theta is equal to minus 5 iota minus 3 plus 7 iota 3 plus iota minus. Okay, if you take minus sign outside, so you will be having inside 5 iota 3 minus 7 iota, here minus 3 minus 7 iota and 9 iota. Okay, which is nothing but okay B. Therefore B theta is equal to minus. Therefore we can say B is a Q Hermitian. Now you see, we did some properties of Q Hermitian matrix. First property was Aij is equal to minus A Ji. So is this property true here? Okay, you see, second property was diagonal elements are purely imaginary, right? See, first property, if you take this element is A12, okay, then what would be A21 in negative and its conjugate? See here, this is A21. If I multiply it by, if I take its negative, okay, if I change it, if I multiply it by minus, it would become 3 plus 7, right? And conjugate, after conjugation it would be 3 minus 7 iota, which is nothing but 3 minus 7 iota is A2. Therefore these two are equal, right? Is minus here. Therefore these two are equal. A12 is equal to minus of, okay, so this property is true. So this is always true for the Q Hermitian matrix. Secondly, you see, diagonal elements are purely imaginary. See, these two are the diagonal, this, they are purely imaginary. As you know, there is no real part present here, so we can say these two elements are purely. So these were the two properties I told you earlier. So this is the illustration of properties of two properties. I'm going to write it for you. I just want you to do it by yourself. Okay, first is A plus B tranjugate is equal to A tranjugate plus B tranjugate. Second is AB tranjugate is equal to reversal law. Okay, B tranjugate. Third is K multiplied A tranjugate is equal to K conjugate A tranjugate. Okay, since K is the scalar multiplication, K is the scalar number which is multiplied with the matrix, so it couldn't be transposed. Okay, so we will be having only transpose on this. Okay, so this is it. This is all about the properties of and Hermitian matrix, and also about the right. So I just want you to examples on one more theorem. Result I would like to tell you here is, it is quite simple that every write it here, every square matrix can be expressed as sum of Hermitian and Skew matrix. Okay, as we did for the case of symmetric and Skew symmetric. Okay, so if A is the matrix, A is any matrix, okay, then we can find out A theta, right? We can find out A theta for this matrix, A tranjugate I mean. Okay, so take P is equal to half of A plus A tranjugate, and Q is equal to half of A minus A tranjugate, right? So see from here, if you take P theta, P tranjugate is equal to half of A plus A tranjugate, which is equal to half of A tranjugate plus, okay, which is nothing but half A plus A tranjugate, which is P itself. So uh, P is Hermitian matrix. Similarly, Q theta is equal to half of A plus A minus theta tranjugate whole, half A tranjugate minus A tranjugate, which is equal to A. Okay, so it is equal to minus half A, it is nothing but Q itself, so minus Q. So therefore Q is Q Hermitian and P is Hermitian matrix, right? So if you add these two, we get A again. Okay, adding yields, therefore any matrix can be expressed as of Q Hermitian, right? So this is all about, you will be having some examples or some problems about Q Hermitian matrix book, right? So you just go through those examples. If you are cannot able to solve problems, ask me. Now I'm going to tell about unitary matrix. I think it's enough for today. Okay, unitary matrix and orthogonal matrix discuss you in next video. Alright. So you just go through this concept of Hermitian and Skew Hermitian matrix. Okay, so with this, this is it. With this, we just finish this video here. If you have any problem or query, ask me. Us.